Alright guys, so welcome back. We are going to be looking at electric field. Okay, so there was a question we were supposed to treat under electric charge. I'll give you that question so we would just address it. It's very important. Okay, it has to do with total amount of charges in a material. When you're giving the mass of the material, you're giving the atomic number, you're also giving the molar mass. How are you going to get the total amount of charge? Alright, so now let's look at a question like that. It's a very short exam question. Put down guys. Determine the total charge of a copper plate. Determine the total charge of a copper plate of mass 3 grams. Given that the molar mass of copper is 63.5, and its atomic number is 29. Given that the molar mass of copper is 63.5 grams per mole and its atomic number is 29. So when you have a particular material that has a given mass, okay, how will you know the total charge? Because listen, that material must be a conductor. Is aluminium a conductor? Yes, because it is a metal. It's a metal. Copper, but in this case it's copper we are looking at. Alright, so in this context it's copper we are looking at. Alright, so copper is also a metallic substance. Alright, so how do we go about that? Now to get the total charge, the formula is NZE. It's NZE, guys. Alright, so N times Z times what? E. Alright, to get the total charge. But then, how do we get N? N is given as mass times Avogadro's constant. Mass times Avogadro's constant divided by molar mass. This N you're seeing here means number of atoms or number of particles. So once you have determined the number of particles, you multiply it by Z, which indicates the atomic number, and you multiply it by 1.6 times 10 raised to the power minus 19, which indicates the constant for the electric charge of a material. Sometimes you see it as E, sometimes you see it as Q. Alright? So how will you now know the total charge in this material? So we have stated our parameters. This is the mass, this is the molar mass, this is the atomic number. Alright? And you know that E is equals to 1.6 times 10 raised to the power minus 19 coulombs. Alright? So quickly we'll be looking at that. Alright? We'll be looking at that. So let's look for our N first. So if we are to calculate N, the mass is 3. Avogadro's constant is 6.02 times 10 raised to the power 23 divided by 63.5. So quickly solve this quickly. 3 times 6.02 times 10 raised to the power 23 will give us what? Just divide everything, multiply and divide everything by 63.5 and tell me the answer quickly. Have you divided by 63.5? So what do you have? Times 10 raised to the power what? 22. Beautiful. I love that. Proactiveness is nice. Good. Now, so we have gotten an N. So now Q will now be this guy times atomic number times the number of electrons, which is of course the constant 1.6 times 10 raised to the power minus 19. So Q now would be 2.84 times 10 raised to the power 22 times your Z. Z in this case is 29. Z is the atomic number, then times, of course, E, 1.6 times 10 raised to the power minus 19. If I were you, I'll multiply this quickly. So multiply everything. What will you get? 100 and what? 131,000 what? 700. Beautiful. So have you confirmed that? So 131 77 what? 6. So let's put this in standard form. So this will be 1.32 1, 2, 3, 4, 5. 1.32 times 10 raised to power 5 coulombs. So that is the total charge. Alright, so that is the total charge. So basically what we are going to bring it up to say that Q is equals to 2.84 times 10 raised to power 22 times 29 times 1.6 times 10 raised to power minus 19. So this gave us 1.32 times 10 raised to power 5. 1.32 times 10 raised to power 5 coulombs as our final answer. Alright, so now let's quickly look at the concept of electric field. Let's quickly look at the concept of electric field. Alright, okay, so electric field is what we'll be looking at right now. So are we ready? Take down, take down. The electric field of a given material is described as the region in which a force attracts electric field lines to a point charge. In which a force attracts electric field lines to a point charge, okay, to a point charge in the material. So that region where there is a force that attracts electric field lines to a particular charged body is called electric field. Now let's call this the charge. Let's call this the positive test charge. Now let's call these electric field lines. These are called electric field lines. These are called electric field lines. So the force that enables this electric field line, this region has a force that will make these electric field lines to go towards the positive test charge. This region is called the electric field. This area where there are electric field lines that are channeling towards a positive test charge is called the electric field. It's called the electric field. So it's a region, it's an area. Are we together? Alright. So now the electric field of a material, right, is denoted as E. The electric field of a material is denoted as E. That is how we express electric field. Capital letter E, not small letter. The electric field of a material is denoted as E, and is given as E equal to F all over Q. E is equals to F over Q. So we can also define electric fields to be the amount of force per unit charge. Simple. Another simple way of defining electric field is force per unit charge. Alright, and of course the unit for E is newtons per coulomb. Newtons per coulomb, which is N/C. That's the unit for electric field, newtons per coulomb. Alright, so if you want to get the electric field of a material, you should know two parameters. You should know the what, and you should know the what? Charge. Divide the force by the charge and you've been able to know the electric field. Most times, electric field is represented as electric field intensity. They are the same. You can be told the electric field intensity and the value for the electric field, they are the same. Alright, so most times they tend to be used interchangeably. Are we together? Are we together? Alright, now let's look at an example. Let's look at the basic example that will help us to draw solid inference to what we've been talking about for the past few minutes. Take down. Determine the electric field intensity. Determine the electric field intensity of a material with an electrostatic force of 60 newtons 60 newtons, and a positive test charge of 1.86 microcoulombs. And a positive test charge of 1.86 microcoulombs. It has an electrostatic force of 60 newtons, positive test charge of 1.86 microcoulombs, and we are told to determine the electric field intensity. Alright, so that is not going to be any form of conundrums, not going to be an issue. Alright, so basically, how are we going to tackle this issue? Alright, so basically we are looking at E, and E is F over Q. Alright, so basically what I said is that a material has an electrostatic force of 60 newtons. Alright, so we are told to determine the electric field intensity of a material has an electrostatic force of 60 newtons and a positive test charge of 1.86 microcoulombs. That's the question. Alright, so E is will now be equal to F all over Q. You know that, right? So our force is 60 newtons, while the charge here is 1.86 microcoulombs. So remember, micro is times 10 raised to power minus 6, right? So this is times 10 raised to power minus 6 coulombs. When we divide the force by the charge, what are we going to get? What are we going to get, guys? 3225 what? 8064 point what? Point what? 0.5. 322 58064.5, right? 52. Okay, let's leave it at that. All right. So let's say 3.2 times 10 raised to power. Move the decimal point. 1, 2, 3, 4, 5, 6, 7. 7, right? 10 raised to power 7 what? Newtons per coulomb. That is our answer. So this is the electric field intensity for this material that has a force of 60 newtons and a charge of 1.86 microcoulombs. Okay, so we'll be looking at another question that will help us to understand more about the concept of electric field. And this time around, we'll be looking for another parameter. We'll be given the electric field intensity and we'll be given the force, but we don't to determine the amount of charge, Q. Alright, so take down. Now the magnitude of electrostatic force, in an electric field, is 40.5 newtons. 40.5 newtons. Full stop. Now, if the electric field intensity on the surface of the material, is 1.85 times 10 raised to power 4 newtons per coulomb. If the electric field intensity on the surface of the material is 1.5 times 10 raised to power 4 newtons per coulomb, determine the magnitude of the positive test charge in the medium. Determine the magnitude of the positive test charge in the medium. And of course, we are looking for Q, we are looking for the charge. We are being told that the magnitude of the electrostatic force is 40.5 newtons. We are being told that still in that region, we have an electric field intensity of 1.85 times 10 raised to power 4 newtons per coulomb. And we have been told to look for the charge, the positive test charge in that medium. Alright, so let's quickly solve that. So as our custom has always been, we have to release our parameters first. Alright, so our parameters, we know we have given our force to be 40.5 newtons. Alright, then the electric field intensity E is 1.85 times 10 raised to power 4 newtons per coulomb. And we have been told to look for the positive test charge Q. Okay, are we together? Alright, so we've listed our parameters. So we know that F is equal to and E rather is equals to F over Q, and we are looking for Q. So if we cross multiply, Q will be equals to F over what? E. Okay, so the first is 40.5 newtons, while the electric field intensity is 1.85 times 10 raised to power 4. So when we divide these two, what are we going to get? 2 point what? 19 what? Minus 3. Minus 3 what? Coulombs. Alright, so that is our answer. Alright, so 2.19 times 10 raised to power minus 3 coulombs is our answer. Alright, so basically one thing we just need to understand is that the general concept of electrostatic force has to do with electric charge and electric field. Alright, so we'll look at another question. I'll give you a question you try online. Alright, so just drop your answer in the comment box. Okay, take down. Now, determine the amount of electric field intensity. Determine the amount of electric field intensity E, okay, of a material with a charge of 5.62 nanocoulombs, with a charge of 5.62 nanocoulombs. All right, if the magnitude of electrostatic force is 0.26 newtons. If the magnitude of electrostatic force is 0.26 newtons. So do well to attempt that, and of course type your answers in the comment box below. Thank you.